Hello, in this video we're going to be looking at square numbers. So the first square number is a unit of 1. Okay, so the shape that I've drawn here is a little square that is 1 by 1. So the value of the length of one side is 1, and 1 squared is 1. If I make the next largest square up from there with whole number sides, that's going to be a 2 by 2. And the total number of squares represented in there is 4. I'll continue along here, so 3 by 3. So a 3 by 3 square contains 9. And then we have 4 by 4. Four squared is 16. And you could count these all up and see that 4 groups of 4 is 16 squares there. 5 by 5 is the next one. That's 25. And 6. Looks like I need new purple. That'll do. And the last one we'll do is 7 by 7. So in each case, I'm just adding enough additional squares to make the next largest square on this grid. So 7 by 7 is 49. So one of the things that's interesting about square numbers, if you look into them a little bit more closely, is how many extra squares I had to add each time. So I'm just going to look a little bit closer at this. So my x values, or my dimensions, were just going up by 1 each time. But if you look at the x squared values, from 1 to 4, that's a difference of 3. I had to add 3 orange. From 4 to 9, I had to add 5 yellows. From 9 to 16, I had to add 7 greens. By now you should notice some kind of a pattern happening here. Can you predict what's going to happen next? So that's a feature of squares, of square numbers, that you can use predictably. So once you know one of the square numbers, like 7 times 7 is 49, to find the next one, you can use this pattern of adding odd numbers, increasing odd numbers. So from 25 to 36 was plus 11, 36 to 49 is plus 13. So the next one is going to be plus 15 from there, okay, following that same growth pattern. So the flip side of this coin is if you are given a square number, you can use a square root in order to figure out what the length of one of the sides of the square would be. So for example, if I was given, so going this direction is square. And going this direction from right to left in this table is square root. Right, so the square root of 49 is 7. The square root of 36 is 6, etc. So square, that's 11 on one side. If I were to count the total number of squares in that object, it's going to be 121. So a statement that I could make that would be true is that the square root of 121 is 11. That's the connection between the area of a square and the dimension of the outside of the square.